China has made significant investments in infrastructure projects over the last few decades, including highways, high-speed railways, ports, and airports. China's leap into the future has left the world speechless, with mind-blowing projects that even American engineers find hard to believe. But what exactly sets these projects apart from others around the world? In this video, we are exploring China's large-scale projects, and their innovative technical achievements have raised the bar sky high. Before we dive into the fascinating details of these projects, be sure to subscribe if you haven't already, and don't forget to hit that like button. Now, let's get started. Over the years, China has achieved incredible progress, not just in the economy but also in construction. Imagine bridges stretching for miles over sea and super-fast trains traveling between Beijing and Shanghai so quietly that you won't be able to hear a coin drop. And get this, they are even planning to build a city large enough for 80 million people. Chinese engineers are considered superheroes in the construction industry due to their lightning-fast construction of massive buildings. It's like they've got a magic wand for construction. China has been investing heavily in its infrastructure in an effort to strengthen its economy and society. People have been discussing China's amazing growth for a very long time. Their national income doubled from 1980 to 1990, and they have been rising in the world rankings ever since. Doubling their income every decade. That's a record breaker. China has now overtaken Japan to take second place and become Asia's top economy, just behind the United States. How long does it usually take other major nations to achieve what China accomplishes in just a few years? Decades. To begin, let's examine the Chinese bridge construction industry. Believe it or not, China is currently in the lead when it comes to the quantity and quality of modern bridge construction. They're really raising the bar, leaving everyone else in their dust. We shall begin with the girder bridge, an ancient design with two single girders supporting pillars. The spans, or horizontal distances between adjacent pillar centers, indicate the bridge's bridging capacity. In 1937, China shocked the engineering community when it constructed its first modern bridge on its own. It's called the Nanjing-Yangtze River Bridge, and it can stretch out more than 66 meters long. Isn't that amazing? This bridge uses a simple yet super strong girder design, with box girders between each pillar. Stretching a single girder into several tons of support creates a continuous girder bridge. Because beams are continuous and unbroken, they can limit one another to produce greater load-carrying capability and wider spans. For example, the Wuhan-Yangtze River Bridge has a maximum span of 128 meters. This design allowed the Chinese to successfully cross the natural barrier of the Yangtze River for the first time in China. At that time, these steel bridges were not only technologically innovative but also expensive, and were mostly used in railway construction. Chinese engineers could easily bridge the Yangtze River with the introduction of innovative bridge construction technology. What is the theory behind this technology? Pre-stressed steel bars buried in concrete use shrinkage to balance external forces. This enables the bridge structure to bear heavier loads and support longer spans. Pre-stressed concrete technology is a more affordable alternative to regular reinforced concrete technology. Therefore, Chinese engineers have been using it to construct a significant number of highway bridges. Girder bridges have already become widely used, producing standard parts that can be factory-made and built on site. Span lengths may be limited, but when you combine hundreds or thousands of them, you can cross rivers, lakes, and seas, and even build bridges up to 165 kilometers long. These bridges stretch way beyond the road surface, making them the longest in the world. However, in order to widen the span, a technological revolution in the girder bridge is required. The outside design of this bridge is quite similar to that of a girder bridge, but the pillars and beams are connected to prevent the girder from bending. As a result, beams can stretch out further or choose a lighter bridge deck supported by pillars, making the bridges stronger and more flexible at the same time. This sort of bridge is extremely sensitive to expansion and contraction since heat can quickly distort or collapse it. To address this issue, Chinese engineers developed taller piers for cable-stayed bridges, increasing their flexibility and lowering the possibility of pier distortion. In places with lots of mountains and canyons, designs with these tall piers are perfect. The mighty Xiong Mega Bridge, with its piers diving straight into the valley, reached a staggering 190 meters. That's as tall as a skyscraper with over 60 floors. It's the tallest pier in all of Asia, but we don't need those towering piers in flat areas. Do you know why cable-stayed bridges with spans greater than 300 meters are uncommon? To reduce the bridge's height while keeping the piers flexible, a unique pier is required. These piers must be narrow, the bridge must be stable, and the expenditures must be minimal. All these issues are connected, making it pretty rare to see these mega bridges around. The Equatorial River Bridge, constructed in 2006 with a maximum span of 330 meters, is now the world's largest pre-stressed concrete continuous steel girder bridge. When dealing with steep cliffs, deep valleys, or the need for clearance, you need an arch bridge to span the entire distance. This arched structure needs both ends to pull the bridge up and provide a strong sideways push. This push counters the arch's bending, allowing for a longer span. For example, the Chinese Pioneer Truss Arch Bridge. Its narrow concrete arch makes it lighter and able to span up to 330 meters. When regular concrete arch bridges hit their limit, more advanced versions come into play. Steel arch bridges are becoming more common as China's steel manufacturing increases. When combined with trusses, steel structures, and other ideas, they have achieved one engineering feat after another. Chinese engineers have developed arch bridges with astonishing spans of more than 600 meters. Furthermore, China intends to build an extra-large bridge with spans of more than 1,000 meters in a short period of time. Now observe the magnificent Yangtze-Wuhan River Bridge. Its main cables are made of super-strong steel wire, forming bundles that create a dual cable configuration. These cables not only hold up the bridge, but also showcase an incredible engineering feat. They can handle steel beams weighing over 70,000 tons, and with such immense strength, the traffic on the bridge seems like a walk in the park. Let us return to the construction of China's Shenzhen-Zhongshan Canal, the world's longest sea-crossing bridge. This large-scale project, which follows the Hong Kong-Zhuhai-Macau Bridge, is a trans-SE cluster engineering marvel that has stunned the world. We'll look at the underwater tunnel, 32 segments of an 8-lane, two-way steel-held concrete marvel spanning 6.8 kilometers. Its construction challenge is unmatched worldwide. But, as always, Chinese engineers find brilliant solutions. There's more. Meet the Yongjin-1, a mammoth cargo ship born from Chinese engineering brilliance. Setting sail from Guam Island, a colossal structure weighing 880,000 tons, headed for the Kan Tunnel site, 50 kilometers away. It's a massive operation. Think mooring, hoisting, and positioning, all underwater, in depths deeper than 30 meters. Docking the 80,000-ton piece with millimeter precision, and there's the Yongjin-1, acting as a giant clamp, securing the last section and final joint underwater. Guided by its onboard brain, it expertly ejects the final joint, ensuring a flawless docking with the E-24 section on the east side. Behold the Shenzhen-Zhongshan Strait Underwater Tunnel, now officially linked, the longest and widest steel-held concrete wonder in the world. It's a testament to Chinese engineering wizardry and a giant leap forward in technology. Despite hurdles like tricky terrain and tough times, China keeps pushing boundaries with new breakthroughs. And just look at the millions of bridges they've built along the way, proof that China's journey is one for ages. China's remarkable achievements in bridge construction not only propelled domestic economic growth, but also elevate its stature on the global stage, instilling confidence in its capabilities worldwide. The extensive series of projects undertaken by China serves as a testament to its unwavering determination and formidable engineering prowess, showcasing the nation's ability to surmount seemingly insurmountable challenges. These monumental bridge-building endeavors not only serve as physical connectors, but also as symbolic representations of China's commitment to pushing the limits of possibility and shaping a more interconnected and prosperous future for all. What are your thoughts on the genius of Chinese engineers and their jaw-dropping mega projects? Share your thoughts in the comments below. Hope you enjoyed this video. Thanks for watching, and don't forget to hit that like button, subscribe, and share it with friends and family.